session, and here we have Kevin and Giri with us. So, Kevin is a senior performance architect at Cognizant, and Giri is a senior associate at Cognizant with 10 years of extensive experience in performance testing across various products and domains. And they both will be giving us a hands on experience on accelerated performance test design using GitHub Copilot. So, let's have a big round of applause for both of the talented man and over to you guys.
Thanks, Pyle. Kevin and Giri, you want to say something while I basically share the screen and play it for you? Okay.
Yeah, sure.
Hi everyone, welcome to the hands-on lab on.
Okay, can you hear the sound, guys?
Yes.
Okay, so I'm going to increase the sound here. Give me a second.
Aditya, if participant has any doubt in between, they can post it in the chat and we can reply them on the fly.
Okay, guys, as you heard, Kevin is saying that while I'm playing this recording for you, this next session, they are available in this session, and because of the rains and because of the issues that they're having with the power cut and all, they will be able to take your questions in the chat and you'll be able to answer that out. Okay, so let's start that. Okay, if you don't hear the audio, please let me know. Okay.
Accelerated performance test design using GitHub Copilot. I'm Kavin Raghavan, a senior performance architect at Cognizant, and I have Giri Shankar with me, who is a senior performance engineer working with me, and we both belong to non-functional testing COE in Cognizant. So today's session is going to on how we can accelerate the performance test design using GitHub Copilot. So before jumping directly into the hands-on, I'll give some quick heads up on what is GitHub Copilot and what we can expect it for performance testing. Okay, so GitHub Copilot, as you all know, is an AI-powered coding assistant developed by GitHub and with Microsoft now, and they have collaborated with OpenAI so that it integrates seamlessly into our coding environments like coding IDs like VS Code, etc., and helps us to get real-time code suggestions. So basically, it's kind of an coding assistant. We can ask GitHub Copilot the prompts, and it will give us a sample code, and can also generate complete files recently. Coming to you may have a question. Okay, what is the difference between GitHub Copilot and ChatGPT, right? So both are two different Gen AI solutions in which Copilot strictly integrates with our development environment so that it supports only coding assistance. So if you ask ChatGPT, it can assist you with n number of items, right? Whereas Copilot is strictly restricted to coding. So whatever coding questions we have, this will be answered. So this is like strictly tied to professional environments. So that is why most of our application teams and developers are getting GitHub Copilot, which will help us, to script faster. Coming to the use cases. So for performance testing, how we can use GitHub Copilot. So performance testing tools like LoadRunner, K6, JMeter, they involve a lot of coding, right? So this can integrate with those code editors and help us, create performance scripts faster and also review them, refine and enhance them. So what are the GitHub Copilot use cases that we can see for non-functional testing? So there are two categories, scenarios where it can be highly effective and scenarios where it can be least effective. Okay, so the API script creation for LoadRunner, API script creation for K6 tools. So these have been found to be very effective cases in which we would be able to create a API script for LoadRunner very faster, say in a fraction of seconds. Okay, whereas web protocol or any other protocol creation for tools like LoadRunner and NeoLoad, it's going to be slightly not effective because recording is not going to be handled by GitHub Copilot. We have a performance testing tool to do the recording, right? So since it cannot access the recording logs, this is not going to help us with the recording or directly checking for the logs to get the correlation variables and those kind of things. Okay, so the second area, script review and enhancement. Say if the performance engineers have already created script and they want to enhance that. Okay, a junior performance engineer has created a script and the lead wants to review or enhance the script. It would be a cakewalk when they can just open the script in IDE and ask Copilot to review the script for us. Okay, transaction names, boilerplates, text checks, custom functions, everything can be added through Copilot. Okay, whereas correlation parameterization, so those things deals directly to the tool, directly dealing with the tools, right? So advanced correlation like auto correlation and auto parameterization is not possible, whereas manual correlation, say like if I find the LB and RB and if I place that in a particular part of the script and ask Copilot to generate the syntax or complete correlation template, it would do. The same goes with code-based inline parameters as well. It can create parameters inline, whereas if you want to create parameters in the tools window, that has to be manual. Okay, so why not only scripting? What are the other areas? It can also assist with creating dashboards, performance dashboards, like where we can create Splunk queries and integrate those queries into dashboard and create visually enriching dashboards. And also it can assist with SRE activities as well, in which it can help us to create chaos experiments, create CI/CD automation pipelines, and can also assist with all our infrastructure as a code activities. Okay. Um, and one area where in performance it cannot be much helpful is performance analysis through Copilot. The performance raw data results, it's going to be very huge, and Copilot has a limit of 4,000 tokens. So any raw data below that, beyond that, is something Copilot cannot read, and it cannot help us with the effective performance analysis. And that is not the objective of Copilot also, because the objective is to assist with design and not analysis. Okay, so before jumping into the hands-on, a quick snapshot of what are the different performance testing tools that are compatible with Copilot and how they are, effective. So the tool which is going to benefit most by Copilot is going to be K6, because K6 is completely script-based tool, right? So whether we want to create a script or whether we want to create a scenario, whether we want to run a test, everything happens through JavaScript. So K6 is highly compatible with the Copilot. And next comes load runner, in which web services, Java protocol, and MQ protocols are very well handled by Copilot. Tools like Neurod and JMeter, which are more GUI centric, takes a hit here, in which it gets moderate support. It can help with code snippets for those tools, but not the entire code or script creation. Okay. So with this introduction, I think it's time to go to the hands-on lab. We are going to take an example how we are going to do AP script design in Loader. Okay, so we are going to create a AP script from scratch in Loader through Copilot through a set of prompts, and we'll run the script in Vusion and validate how it's working. So the workflow that we're going to adopt is we are going to create a new loader script, and we are going to create the open the script in VS Studio Code, and then I'm going to parallel input the prompt template to the tool. I mean to GitHub Copilot, which contains details about the APIs, the request endpoint, the request parameters, payload, everything. Okay. And then the script is going to get generated, which will be inserted into the Vusion script through VS Code, and then we'll be running the script in Loader. So this is the flow that we're going to see today. Let me jump to the demo. Okay. So as a prerequisite, let's create a new empty script in loader. Okay, add new script. I'm creating a web HTTP HTML script, and I have a empty script. Now I'm going to open VS Code. I'm going to open the newly created script there. Okay. Now I have the script opened in VS Code. So this is my VS Code editor, and whatever changes I am making here, it's going to get reflected in my views. Okay, so this is the setup we have. Now we are going to create an API script for this endpoint, JSON placeholder.type code, which is a globally available test API that everyone can test. So I'm going to test this API. Okay, so the first prerequisite is creating an empty script and opening in VS Code that we have did. The second thing is creating the prompt template. Okay, so this is the prompt template I'm having, in which I'm going to input, hey, create a new loading script for web services SOAP project using web HTML protocol, and follow the sequence I'm instructing here. And I'm going to give a set of instructions for Copilot. Say wrap each API call into a separate transaction, include error handling, include parameterization. And since it's an API, we can direct to do correlation using the LBRB which we give. And I'm also giving it to some basic directions to API scripting, the base URL, the endpoints, everything I'm giving. Okay. So this is a prompt template, and if you want to reuse this, you can just replace the base URL, endpoint, and the request endpoint here. And if there is any, say this is a get request, right? If you have a post request, you can post the request payload here. Okay. In other way, if you have any API tool like say SOAP or Postman, you can export the curl request, and which contains the authentication information, request headers, request endpoint, request payload, everything, and just paste it here. That would be able to convert the curl request completely into a loading script. Okay. Now I'm going to copy this. Go to VS Code, click on Copilot chat, and I'm going to give the prompt template. Now we get a very basic script. If you can see here, it has created the script in which it has hard-coded the request endpoint, and then it has added a default text check called success, and then it has created the web underscore URL loader function to uh, hit that get request and check for a response and return in the transaction. This is a very basic template, right? So now we have to customize this. So it's not sure whether the response contains the word text, right? So let's go and check the response manually. So if I see the post response, it is containing user IDs, title, and body. Okay. So I'm going to copy paste a portion of the response. This is my sample response. Update the text checks accordingly. So now you can see it has given 4 text checks based on the response, sample response which we gave, and also it has created a if else logic to check whether the transaction is getting passed as per that response. Okay. Now, if I want to have a correlation, for example, if I want to write the response to a notepad file, okay, add a logic to write the entire response to a text file. Okay, as you see here, it's capturing the entire response and writing to a response.txt in the same file. Okay, now, as you can see, if we go to ViewGen, the script should be automatically updated, and we have the script here. Okay, and say what else we have to do normally in a loading script. Okay, now we have to add correlation, right? So what can we correlate? Let's see the response. So we are seeing user IDs, title and body, right? So the user ID and ID are the different things every time, right? So let's correlate user ID and ID. So if you see here, since we have already passed the sample response previously, it, it is able to construct the correlation variable automatically. If you see here, webred save param of user ID equal to user ID, LB and RB is user ID and RB. Let's validate that quickly here. So LB is user and RB is ID, right? So it has given the correlation as well. Okay. Now, say let's add another request to the script. Say now we have get all the posts, right? Let's say like if we want to update any of the post, for example, if you see our sample request which we have 5 APIs in this web service, like post, comments, albums, photos, to-dos, and users. So now we have got all the posts, right? Now let's try to update or like post anyone or get a particular post. Now we have received all the if you click on this post, it's going to get you all the list of posts available, right? Every post has an ID. Now let's try to fetch a script based on a particular ID. Okay. So for that, the sample request is this, and the endpoint is this. Okay, so the first transaction gets all the posts, and from those posts, I'm going to randomly select a post now. Okay, so for that, what it should do, it should correlate the user ID and so correlate the ID of the post in ordinance equal to all, and capture a random value from that ID. Okay, so randomize the ID correlation variable using LR param R and pass it to the second transaction. Okay, now let's go the script from the start. So we have all the headers included. We have the action started. We have the start transaction for fetching all the post, and then it is adding 4 text checks to make sure all the posts are properly fetched. And it has also added a correlation to fetch the complete response and write it to a notepad file. And it is also correlating the user ID and ID here. And we are fetching all the posts now in the first transaction now. If the transaction is successful, it is writing the response to a notepad file. Okay, now this portion handles the randomization here. Okay, so it's randomizing the user IDs captured during the first transaction and picking a random ID, and saving that random ID in a loading parameter, and it starts the second transaction, which is fetch random post. The first transaction is get all post. The second transaction is fetch random post. Okay, so here, if you see here, the random post ID is sent. Okay, if you see the base endpoint, which we saw, to get all the post, it's like the host / post. Whereas if I want a particular post, I have to give the ID of the post. Okay, say let the random number be say 5. It's going to take 5 and get the post. Okay, now the 5 is getting passed into the request endpoint, and we get the second transaction. Okay, so now these are the basic actions we do for a normal API script, right? Now let's try running the script and see how it works. Okay, so there could be small errors then and there, which we have to capture and put it in Copilot again to fix that. But here what we can do is let's run the already validated version of the script and see how it is giving the response. Okay, so now if we see the response, what has happened? Okay, so first it has written the entire response, which we saw here. Okay, if I click on post, this is my response, right? The entire response is written here. So when the transaction is successful, we are writing the response for validation. Okay, and then it is like capturing the text checks. So at a total of 100 user IDs are there, and 192 IDs are there, 100 title counts and 100 body counts are there. So if you see here, there are a total of 100 values for user IDs and body count. So it has captured the values, and these are the text check conditions. The text checks are passed. Now it has let's go back to the correlation. So the correlation value which I have given is the user and ID, right? So if you come back to the script, so it has captured all the post IDs. Say there are 100 post IDs. All the post IDs and IDs have been captured, and random post ID is picked, and then the particular response is fetched. For example, if I'm clicking the random user ID 5 or sorry 43, and I'm getting the corresponding response here. Okay, so based on this texture, this is getting this transaction is also passed. And if you want to check the output file, probably it's also going to help us write all the user IDs and IDs to the output file as we request. So basically, this will be the first time when we create for any new application, right? So then and there few refinements may be needed. Now, once this is created, this whatever we instructions we gave separately, right? All those prompts has to be connected into a single prompt. Okay, for example, now to understand how this works and to make sure Copilot is tuned to give us a proper response, we are like giving individual prompts, fine tuning the response and getting a successful script. Okay, now say if we want to do this for some 10 APIs, okay, now we have to update the prompt in a different way. Say I'm going to give detailed instructions like small syntax or templates that you need to follow. Say like we have to disable the SSL certificate verification, we have to increase the correlation value to say a particular amount, and what are the values to be parameterized, what needs to be correlated. So everything we have to like give a detailed instruction, so that once you copy this and use it for a different request, um, like say within a single click or like with two refinements, you get the complete um, working API script here. Okay, so this is how we would start API script design with the GitHub Copilot. Now let's not talk only about API scripts, right? Let's talk about a few other protocols as well. So okay, say if we have a Java protocol. Okay, so you want a JMS protocol. You want to post messages into a MQ. How we can handle that? Okay, so we get the syntax of the MQ protocol script as well, where we can simply replace the MQ server details, queue name, channel names accordingly. Okay, so this is the default template again. We can refine this with our existing knowledge, like say using the different prompts, and make it a complete reusable script for any protocol. Okay. So this is for MQ protocol, right? So we don't have any public MQs available to test this, but this is how we create for other protocols as well. Now, let's imagine we have a web protocol script. Okay, so we have already recorded the script using Vision. Say we have a web script here, which we have already recorded, and we have a recording log, we have a generation log, everything. Okay. So how what kind of support Copilot can do for those scripts? So in the same way, how we open the API script here in VS Code, we have to open the web script in VS Code through this option, open folder, and then we can then and there select the part of the code and ask if we need to have any assistance with it. For example, if you want to insert a logic here, okay, insert logic to generate random number. Okay, it's going to help us create logics inside that script. Okay, in the same way, if I have a confusion with the correlation syntax for any random variable. Okay, sorry, for any random response which you know the LB or RB. Okay, so okay, so if I want any of the scripting assistants, like say if I want to know the syntax or something, that can also be did like this. So for web scripts, it's just going to be like a script assistance, whereas for the other protocol scripts, it's going to help us create the complete script with whatever inputs we give. Okay, so this is how you can start with trying Copilot for a basic performance script. Probably we talk more about load runner, right? Let's have some snippets in it for K6 as well. Okay, let me go to the prompt template. Instead of load runner, let's make this as a K6 script. I'm going to update the prompt accordingly. I'm going to remove the load runner specific syntax. Okay, so okay, so this is the equivalent script of what we did so far in load runner in K6. Okay, this script is going to call the request endpoint which we were hitting and get the response in the similar way. Okay, now here I can ask whatever I did in my load runner script. So now I'm asking it to add transaction names, text checks, correlations, if else logic to pass the transactions accordingly with the text checks, and write the correct values to your file. Also, there's a feature called thresholds in K6, in which we can define the thresholds in the script itself, which acts like a performance SLA. Okay, now I am hitting this. Okay, so this is the complete K6 script in which it has defined the SLA thresholds here, where if 95% of the requests are not below 500 milliseconds, it would cause the transaction to fail. Okay. And if you can see here, it has added the headers for those API, started the transaction, and implemented an error handling using that. For example, if the response of the request is giving a 200 response code, it is going to be success, else it is going to be fail. Okay, and then it is from the JSON response, it's correlating the post ID based on the previous request endpoint which it gave, and it is also writing the correlated value to a text file and passing the transaction. Okay, and it is like the think time. So if you can see, converting between loader to K6 scripts or K6 to loader, or converting Postman APIs to K6 or loader. This is going to be very straightforward because of GitHub Copilot. So the speed in which we do this scripting is going to improve, so that once we receive the APIs from the application team or dev team, within a few hours we would be in a situation to completely load test the application or the APIs. So this is going to be the key advantage of integrating GitHub Copilot for the performances design. Coming back to the presentation. Okay, so I think we saw a quick demo of how GitHub Copilot works for load runner, multiple protocols in load runner and K6, right? So now what are the limitations and other considerations we have to do? So GitHub Copilot uses a limited context window. For example, it can only consider a certain amount of code at one time. For example, I cannot copy paste the entire script into this, entire web script into this to ask for a review. For example, let me exhaust the token limit by giving a very huge script. Okay, imagine a web script which will contain more than 500 lines. Okay, if I'm copying the entire script and pasting it into the Copilot, saying that review this script. Okay, it's going to throw us the error. Sorry, this message is too long. Please try a short request. Okay, whereas if I don't do that completely, and if I just do the simple script, review and refine this API script, this is going to do for this. So which means the context window of GitHub Copilot is limited and we cannot exceed its context window. So that is the primary consideration. So dealing with, when you are dealing with small APIs, when we are dealing with small web scripts, this is going to help. Even for huge APIs also, this is going to work because you can combine multiple APIs into a single script and we can do this, which means this makes it more efficient for APIs at this phase. Maybe in the future, if they're going to increase the context limit, like how GPT-4 and other models have, this is going to help in that time. Okay. Now, impact on the suggestions. Okay. So that's what we saw right now. Incomplete code understanding. So say if I'm having a very huge load in the script, okay, which we did right now. Like we have a 500 line load in the script, and if I'm selecting the entire 500 line of code, and if I'm asking Copilot inline, okay. So if I give an instruction like this, selecting the entire code and giving a common instruction to add all the transaction name, it's going to make going to have few challenges. It if you see we had a 500 line script, but here if you can see now it's a 100 line script, which means when you work with a very huge script, this is going to pose some challenges. So the suggested alternative is, say, even though if you have a very big script for 500 lines, just select the part of the code that makes sense for you or that you need help with. For example, I'm just selecting the particular part of the code now, and I'm going to Copilot, say, review this portion and enhance. It's going to do it, right? So this approach we should follow. Instead of like selecting the entire code, we should go the portion-based approach for web scripts if the token limit is high. So, considering the benefits this offers, the limitations seen from Copilot is very minimal, which outweighs the benefits it's seen. So, still, this is a very good option to accelerate the script design. Now, let's quickly see a comparison of the different features in LoadRunner, K6 and other tools Copilot supports and what it cannot. Okay. So if you see this table, this is GitHub Copilot in LoadRunner, in which you can see writing basic scripts, advanced scripts, parameterization, correlation, error handling, transaction naming. Each of these activities that we commonly do in LoadRunner, right? This has been evaluated, what it can assist, what it cannot assist better, and has been, evaluated. So on that, as he said, writing basic scripts and adding complex logics, implementing text checks, transaction names, they all worked fine. Whereas the parameterization and correlation had some struggles because they needed to have a look at the generation logs and everything, right? So for web scripts, that is the partial support which we get, whereas for API scripts, the complete support which we got from here. Okay. So if you can see, it can assist with most of the activities for performances design for LoadRunner. And as I said, for K6, this had more support than LoadRunner, actually, because as I said, K6 is completely code-based scripting approach, right? So there, we had evaluated all the features, and we could see almost every K6 activity Copilot is able to assist. If you see JMeter, which is a completely GA-based tool, sometimes the complete JMeter XML exceeds the token limit of Copilot. So JMeter also has some partial support for Copilot with respect to bean shell scripting or like say custom adding custom pre-process, post-process. So those adding Java codes. So for that, it can still be used for JMeter, and the same case goes for Neoload. So JMeter and Neoload follow the same J-based approach, right? So for both of JMeter and Neoload, the support has been slightly partial. Okay. Now coming to the conclusion. So based on what we have seen so far, right? Definitely GitHub Copilot is going to help create scripts in a much faster phase for junior performance engineers as well as test leads to review the scripts and also to create scripts in a very faster phase. Okay, so we have seen considerable values like quality improvements, reduced errors in the scripts, and quicker and accelerated scripting. So when we have predefined templates, it's very efficient. And also when we have multiple endpoints, say like 10 APIs can also be combined in a single vision script or K6 script, which helps you to complete 10 scripts in a single click. Okay, and comprehensive script elements like all the features like text checks, transaction names, headers, logics for pass and fail, everything can be added automatically, which helps us to like even though if we don't have much understanding on the syntax of each and everything, still we will be able to script it quicker. And again, the cost efficiency, right? So it approximately saves 2 hours per script in average. Like say if we have medium, simple and huge complexity scripts, at average it's helping us to save 2 hours per script, which is like significant time savings compared to the faster development cycles. So with this, we come to the conclusion of this session. So feel free to post your questions. I'll be answering whatever questions you have with respect to GitHub Copilot for performance testing. Thank you all for joining the session.
Hey, hi guys. I think the recording went okay. I don't know how many of you could actually do it with Kavin. Due to unfortunate reasons, we had to do this as a recording. So Kevin, Giri, are you still there? And if people have their questions, you can actually do that. So there are some questions which I can see. I think Giri is already answering them. Shrikant Pandey has one. With many AI code assistants available in the market today, similar to GitHub, what specific, like GitHub Copilot, what specific features or capabilities excite you the most about choosing GitHub Copilot? So, Giri, Kevin, one of you can help. Acha, he is answered. Copilot becomes bundled with Microsoft suite of apps, which makes it easy to organization to manage, right?
Yes, Aditya, we have answered all the queries which was
Yes.
posted in the chat.
Correct,
Yeah.
correct. I was basically, since I was playing the video, I was just seeing it. Any other queries? Anything that you guys want to ask? Anything specifically, guys? You can unmute and speak if you want to.
Wanted to see a slide where we have a for GitHub with JMeter. Can you show to us again
Uh,
in
so
the
this,
video?
so this was mere. Let me see. Which do you know? Because it's a video. Sharing that slide would be extremely
Yeah.
It was
difficult.
we were mainly focusing here on load runner and
No.
K6 kind of
Yeah.
tools.
But there is one slide where you're showing that what you can do with GitHub with JMeter.
Okay, we can preview that. I mean, we can go to that respective duration and show that for JMeter.
Okay. Let me
Like,
do that. Yeah. Let me play that again. Do you remember where is that?
It's the very end.
Stop me whenever you see that.
Or if you can share the presentation as well, that is also fine.
So is this one? No, this is basically I'll load runner
You're
skill
not
then.
sharing the screen, Aditya.
Okay, 1 minute.
probably it should come after 35th minute or 40th minute like that.
35, it comes
Yeah,
to
go ahead. Yes.
still ahead.
No, yes. More. Yeah, it's GitHub Copilot in role runner, then it will be a K6, and then we have for JMeter. Yes, go ahead. Yes, this one. Just a minute. Just before this new load.
This one,
Just before this new load.
GitHub Copilot in JMeter, correct? Can you see the
JMeter,
screen?
GitHub Copilot in in new. Yeah, this one.
Okay. Yeah, you can ask the question.
Yes, thank you.
So what was the question?
Yeah, nothing. I wanted to see that what we can do with GitHub.
Oh, okay. All
That's
right.
it. Nothing else.
Okay.
Do we have any more questions for Giri and Kevin?
So for JMeter, mainly like it will be helping us in writing the custom codes rather than this HTTP based web script recording due to the existing token limitation. As like in load runner we have, right? Apart from API kind of scripting, it will not be feasible in recording the web script, right? So the same kind of limitation we have with JMeter also. So
Okay.
mostly it will be helpful in writing the custom codes.
All right. Excellent. Thank you so much, Giri. Thanks, Kevin.
Yeah. So thank you, Kevin, and thank you, Gary. Here we had again another wonderful session for performance test design using GitHub Copilot. So thank you so much for having us and for sharing the knowledge with us.
Yeah.
So I
So
guess
thanks for everyone, especially for Aditya for understanding our situation because it was raining heavily here in Coimbatore and the power cut was there from morning. So laptop battery is almost drained, and fortunately we have recorded this predicting
Yes.
this weather condition 2 3 days before. So thanks and apologies, Aditya, for this
No. I
situation.
think this is really nice of you that you could actually, as a backup, you guys thought that it might be prudent to record this. And I'm glad that we did it together to make sure that at least we could play it. And thanks again that if since your laptop was not there, you could still come on your mobile phone and do it with us. Really appreciate both your presence and Kevin's presence today, in spite of so difficult situation you guys are in. Thanks a lot.